Okay, we can go now? Okay. Hello and welcome to Assembly 2008, this seminar. I'm really happy to be here. My name is Szelei, also known as Gergely of Conspiracy. I'm really happy to be back in this room, which is where I gave my first seminar in 2004. And especially happy because this room doesn't have a smoke machine as we suffered through 2 years ago. What I'm going to talk about right now is XNA, which is Microsoft's cross-platform framework for developing for the PC and the Xbox 360 at the same time, and its extension, which is XGSE, XNA Game Studio. Now, I had the chance to briefly talk to some of the Microsoft people here. That said, I'm not affiliated with Microsoft in any way, so if you see large black men dragging me away, that's something I shouldn't have said. I'm not planning to show a lot of code here. I'm not planning to go into certain methods, certain exercises of how to use these things. I'm just willing to give an overview and some possible good ideas to go through. I'm not assuming that everyone here is a coder. I'm just assuming that some people here are interested in the fact that they want to do demos with XNA. Now, I would not like to actually separate demos and games. Essentially, they're the same thing, with user interaction added on one side and some sort of unpredictable flow. But I do think, as long as you're thinking about graphics, and which is what we're mostly talking about, and audio, and also basically the entire receptive experience, it's very equatable, so I'm not going to separate it most of the time. If I do explicitly, I will note it. So let's talk about what XNA is and what XGSE is. XNA is short for XNA is not acronymed, which is probably following up what GNU means in the terms of weird acronyms. And essentially what it is it's an extension framework, an extension library to the .NET framework, which we all know is basically this whole wraparound for all the features you can have in a computer. XNA extends that with a sort of simplified, more stripped down, more cleaned up interface when it comes to developing graphics, music, visuals, interaction, all that stuff. And it's all in managed code, so you can pretty much reach XNA using your favorite C# compiler, which is Visual C# Studio. And it's a really convenient way to approach things, and I will detail on that. So what's XGSE? XNA Game Studio Express is even an extension to XNA in terms of it's a set of plugins to Visual Studio C# Express. And what it does is that it adds a few lines of boilerplate code to XNA and allows you to have several templates for what they call games to be able to start your game and prototype it. Basically the whole XNA XGSE concept is built on the boilerplate thing. When you have a lot of code you have to reuse or build every time you're making something, just opening windows and loading textures and all that kind of stuff, which is just really annoying if you have to write that certain set of code over and over. It's just something that rips away from the creativity. So what they did is essentially build a whole system around that, and you can just start actually coding your game within the matter of really minutes. Really minutes, and I will get to that later, that it's a really simple code. And XGSE also comes with this added feature of being able to build your game to Xbox 360, obviously. So if you have a 360 console with a couple of labs you have to run, you will actually be able to enjoy your game or demo on the Xbox 360, as we were able to see that last year when we had, I think, 4 demos in the demo competition which were running on XNA. So why is this a good idea? Now, a lot of people seem to have a misconception that XGSE and XNA is actually coding on the Xbox. In some way it is, but you're not actually building bytecode for the hardware. You're still in a managed environment. You're still in a shell. So you're not actually, being all Amiga and touching the hardware and being just being able to hack whatever you want. It's still a really restricted environment for that. But it is the same hardware that runs I don't know, Ninja Gaiden and GTA 4 and all that stuff. So if you have a powerful hardware like the Xbox, it would be a bad idea not to use it. It's really easy to code. As I said, a lot of it is boilerplate code. So it has been already written by people at Microsoft who will developing the XNA forums. And as I mentioned, the XNA forums are a really good source to be able to find a certain technique that's, when you're using an already built framework, you have a problem of trying to follow your own already well-beaten path for certain things, and maybe looking for timers and looking for file opening methods, and you can get a bit lost in that. But XNA forums are great, so I have no problem recommending them. And of course, you have the demo running on the Xbox 360, which is just for the novelty value of having your Xbox 360 that has these all amazing games. And then you can make your own demo for it. And it's a beast. I mean, it's really great hardware. You can go into really, really impressive frame rates if you write your code good. Sure, you're still in the managed environment, but as long as you respect those rules that it has, then you won't be having a problem. So at least for me, it was a really cathartic feeling just coding on a laptop, pressing run, and then the demo appeared on the HD TV. So that was kind of something that's like almost console development. It's not really that, but it's close enough. It's a good step towards it. And also, since it's essentially developed and devised by Microsoft, I kind of hope, and I'm looking at the Microsoft people in the audience here, that there will be some sort of like distribution method eventually for people who make XNA stuff, XNA demos, games, whatever, to be able to actually have a central kind of archive for it and then just send it there and all people can see it. And you would have a whole new audience. Demo people would be able to show demos for the gamers, and game development people would be able to present their games to both gamers and demo sceners and all that. So I think this is something I kind of expected from the XNA development team to be able to do that. And I read that recently that they've been thinking about expanding the platforms of XNA. Since it's not platform specific, you can use XNA on your PC only. You don't have to have an Xbox for it. They've been actually thinking about extending to Zune, which is the MP3 player from Microsoft, which is kind of cool. I mean, if you can write the cross-compiling code that actually runs on every platform that's possible, then you would have your demo running on the Zune immediately, essentially, which is cool, which is something I really enjoy, that you can make your demo high-res and portable and running on everyone else's computer as well. So there's a lot of possibility in it. But there's also a couple of downsides, at least I would like to mention, is that it's managed code. Now, if you're the kind of person who opens his lines of code with the letters ASM, you might not be actually enjoying it. And the fact that you have garbage collection, and the fact that you have to watch what you're allocating, and the fact that everything is classes and there's no real actual trackable flow of the code. You don't really know what actually the framework is doing behind you, especially because it's all abstract. So that's just something I'd say as a personal preference. If you enjoy that kind of thing, then you won't have a problem. If you're not really into that kind of thing, then you might be able to have a problem that's struggling with it. But this is just a paradigm. This is something kind of like switching from assembly to C to C to C++ to C++ to C#. So it's all kind of up to how open you are when it comes to programming. So I don't necessarily see this as a downside. I'm just mentioning it as something that might be some sort of like a perspective issue for some people. Now, the bigger downside is that currently it's not free. All I've been told a couple of minutes ago is that for students, there's a program that you can get the license for free. Otherwise, it's $99 a year to have a license to be able to actually transport your code to the Xbox. It's still free for the PC, but you have to have a license on Xbox Live to actually be able to run your code on the Xbox. So you can make your demo on the PC with XNA without a problem, and maybe find a friend who already has a license and see if it runs on the Xbox which might not be actually that logical, but I'll get to that later. And also, it's because of the managed code. It's not the usual way of demo coding. You don't have the opportunity to think the same way as you would normally do, just by thinking of dropping effects on screen and just working around. And that's most of the part I will be talking about. That how does this differ from normal demo coding and normal game coding? So this is a bit, well, small letters, sorry about that, but this is essentially how the XNA Game Studio code looks like. The whole thing is essentially derived from this class called game, which is a part of the XNA framework, and really it's all as boilerplate as it can get. All you have to do is override the method for the initialization and for the rendering. Now, if you ever coded demos, most demo coders had this thing that all they need is init and render. And this is pretty much it. I mean, that's what I experienced with the Pocket PC as well, with the game API, is that you have open window and flip screen. And that's a really great way to work. Sure, you don't have to think about stuff like having a problem with things getting in our way, and you have to open the window and you have to set your correct back buffer mode and all that. Sure, it's something when you're really an expert in coding OpenGL and Direct3D, that's something you eventually get used to. But when you're just a beginner, or you just want to code a demo, or you haven't coded in C# before, let alone XNA, it's just something you don't want to bother with. It's something you want to get your effect on the screen. You want to get your game running. You don't want to fiddle around with window handles and back buffer interfaces. And that's perfect for that, because it is basically the perfect demo interface. You just don't have to think anymore. The only downside I kind of experienced that it kind of kills the concept of the loader bar. Now, the problem with that is that the draw method actually handles the flipping of the screen, and you cannot call that explicitly. So while you're doing your initialization, the black screen is all you get. Alternatively, you can just skip the initialize procedure and stick to the draw and do the loading there. But then again, there are obvious downsides to that as well, because it actually breaks the whole object-oriented principle and stuff like that. But it is probably the most convenient way to actually start demo coding, is that the actual system kind of says to you that I don't want to get in your way, I just want you to be able to actually render stuff. There are a couple of really cool things about the XGSE. If you ever use Direct3D, I'm not sure if, I kind of stopped OpenGL coding a while ago, but I don't think OpenGL has stuff like texture loading and stuff like that. But it does have like matrix setting functions and all that. Everything is in there. All the XNA framework has all the matrix operations, vector operations, splines and frustum culling and all this kind of cool things which normally you would need to write yourself, but is also in Direct3DX. You have the Direct3DX texture loading functions and all that. So everything is in there. Everything is really in there, and you don't really have to bother writing your own matrix multiplication, because you don't have to. It's in there, and it's tested to work. I mean, it's nothing's worse than finding a bug in your vector editing and stuff like that. So it's all in there. One of the cool things that actually is on the front page of XNA, or something they've been really advertising, is the content pipeline. What essentially that is that they provide you with this object instance that is able to actually load you your textures and shaders and sounds and everything related. Basically what it does is that it's a templated piece of code that's able to manage all your resources, textures and anything you can imagine, just by itself. Essentially, it's a really, really polymorphic vector, texture loader, music loader, and all that stuff. What it's good for is that it's really saves you the time of actually managing all your resources. You just have to include them in the project, and when you come, Oops, sound way. Oh, we still have, okay, it works. So all you have to do is actually just add your textures to the project, add your music to the project, and it will take care of everything, of all the conversions, all the texture formats and everything. All you have to do is specify the name and it loads and you have the resource. You can assign it and then you can render with it. And that kind of comes together with the resource pooling thing. And the resource pooling is just a really good method of, because it's managed code, it is an upside that you don't have to actually bother with managing your own memory, which is, from talking from experience and having seen a couple of demo engines, is something that's not really existent in demo engines. They just allocate and never really actually care about how much they allocate and how they allocate it. For that, resource pooling is something that's actually really, really useful, although it does come with the fact that it's always like certain like garbage collectors going around and affecting, and I'll mention that later. The distribution package, essentially the CC game, is something, another nice thing that I kind of found funny, that it affects the demo scene in like the kind of crude way it should, because demo scene is traditionally just, I mean, the worst part is when you have like 10,000 textures next to the executable file and there's no data file, there's no data directory, there's nothing basically. Everything is just crammed into one zip. And that's kind of not nice when you think about it. It's a bit careless in a way. But when you actually develop for the PC and the Xbox 360, you have this option called deploy, which what it does is it actually crams all your data into one nice compressed file called the CC game. And you can just press enter on it. If you have the XNA thing installed, you can press enter on it and it runs. So it really leaves a nice chance to actually clean up for you. Again, it's a boilerplate kind of thing. It's something that you waste minutes before the deadline with. But in this case, you just click deploy and it does all the work for you. One thing I enjoyed about it really is that it forces you to write high-level code. You can't really do hacking. You can't really do ugly methods. You have to be a C# coder. You have to follow the C# principle. You have to actually well-structure your code. You can't really just do the whole demo in one big main loop with all the rendering and all like that. And the same way, when you're writing a game, the thing about writing a game is that obviously games, when they release, they eventually become version 1.1, 1.2, 2.0. They keep having features. And a lot of games I know stall because adding features is actually a hassle because of really bad base code. And that's something that happens with demo engines as well, that, you know, the Graphition would like to have Glow, but you can't support Glow because all the shaders are like in 10 different code pieces in the file, and adding them would be pretty much a work of a week because it's bad system design. And that's something you can't afford right here. Something you're not allowed to do right here because of the rigidness of C#. So you have to actually go by the book and go by something kind of you learn in school. So that's something I saw as code reusability, basically, that once you started that high-level coding, then you will find it that it's very easy to actually do a new effect just by, you know, doing 3 lines of code. Again, boilerplating. One of the funny things I found is that the Xbox has a vibratable controller, and that's something people tend to forget. And I'm not sure if it's usable for demos, but I think it's something that, I mean, if the feature's there, why shouldn't we use it? And it's just something I found funny, that there's the chance to actually go to that level. You can't really use the safe games and stuff like that in the XNA Game Studio, but the controller vibration is at least one of the little tentacles they let you into the deep end of the hardware. Now, there are a couple of issues with managed code. I'm not saying managed code is, you know, the next big thing. I'm saying it's really useful. But there are a couple of issues you have to be aware of. It's not really an issue if you do it by the book. If you start hacking, like we did last year, you will be running into problems. The first thing is that it's still managed code. So when you're writing code, it's compiled into some in-between bytecode, and that will be run by a framework that's running with like just-in-time compilers and stuff like that. So once you actually start to do operations and mathematics and memory management, you will run into problems if you try to process, say, 100 megabytes of data like we did. What we did last year is take our intro engine and port it. Now, our intro engine uses generated textures and generated meshes, and everything else is procedural. Everything's procedural. So we have 100 megabytes of data, and you have to go it through by byte because you can't use the content pipeline because they're not standard textures. So you actually have to just pre-process the whole data and then just use the texture writing functions, which is great because XNA still allows you to lock a buffer and load data into it. We actually had to use that, and we went through like 100 megabytes of data. That wasn't fast. That's why the loading is really slow in our demo. And you can actually use the unsafe mode, which is something that's, well, I'm not saying it's discouraged with C#, but it's something that's probably there because it's probably a good idea to be there, but it's not something that should be the basis of the engine when you're writing 100 megabytes of code, or you're processing 100 megabytes with data with a lot of code, and it's entirely unsafe, then it's probably just not worth it doing it. But it works on the Xbox as well. So that's something that when you're processing a large amount of data, that's something you should be doing. That just go to unsafe mode, quickly pre-process all the data you can, and then just quit unsafe mode and be all C# again. The garbage collection is something that is avoidable in a certain way if you're using C#. The problem is both demos and games are going more and more spectacular, more and more high res, and if you're using large amounts of memory, it's essential, especially when you're doing animated stuff, like if you have particles going on, if you have skeletal animations and stuff like that, you're bound to allocate some new stuff, especially with particles, because with the particles you could basically have this undefined arbitrary set of entities in space, and they keep dying and reborn and dying and birthing. So you don't really know what kind of set you're working in, especially when you have to convert all those points in space into like trails and actual vectors and polygons. That's something that's going to be unable to be coded in static. So you have to actually do some sort of allocation, and then you have to deallocate again, and the garbage collector will actually go in the way where you're rendering your frame, and halfway you will have like this every, I don't know, 60 frames you have like this bit of a jitter. So once you've realized how to avoid garbage collection, there's an instance of the garbage collector is actually accessible from XNA called the GC point total memory. Once you can actually like write a little debug text on screen, and once you see that the memory drops and there's a jitter in the screen, then you have memory issues, and then it's time to actually dig out a tool and use something like dot trace or resharper to actually find out that your code is leaking somewhere. So that's something that can affect the frame rate really bad. With the pre-C framework, the biggest problem I saw is that you have to actually have the correct .NET and XNA framework thing, and that's a bit of a hassle with all the .NET framework demos that don't even really use XNA. It's just that XNA still adds another issue, even though it's only, as far as I know, 2.2 versions, 1.0 and 1.1 refresh, but it's still something that the end user has to have installed to watch your demo. And knowing the audiences nowadays, it's a bit of a, well, unless you want to redistribute your entire XNA framework installer with your demo, making it probably twice the size, that's something you have to be really clear about, that you can download this here and you need this because it was written a certain way. And of course, then you might get complaints. With the 360, the issue I found is that you can't cross-compile by just switching the platform because there are no platforms defined. When you create a game project for the Xbox and when you create a game project for the PC, they won't be able to work on each other. So what you have to do is actually create a solution file for the PC and create a solution and project file for the 360, and then just use the same source files. And if something differs, then you have to just ifdef xbox or something like that. Standard way. Luckily, XNA supports that, unlike Java. This isn't really an issue, it's more of an inconvenience thing but I did hear that they're planning to actually some sort of like merge the whole thing together. And for the demo people, I'd like to mention that I don't think 4Ks are possible, that the files in the end are beginning to get too big, the executable itself. 64K might be possible. Our entire demo engine compresses down in the CC game to around 30 or 20 kilobytes. I'm not sure about that. I haven't actually made any tests, but I think it's possible to actually have some generators and work things. And I really don't know about the sound, because XNA doesn't give you access to the frame sound buffer itself. You can't actually have a synthesizer inside. What you can actually do is synthesize waves, save them somehow, and maybe load them back somehow as an actual rendered wave file. I don't know if that works. I think JMagic of Complex has been doing something like that. This is a rumor, so I'm not implying that that is actually true, but I guess it might be possible. It's something I have to try out. Now, what's something that, in terms of XNA and Xbox 360, sort of something you have to consider, something you have to be aware of, something that can bite you in the backside eventually. One thing is that if you're using shader bytecode, if you're a lunatic like myself and use shader bytecode, like actually differently assigning vertex and pixel shaders, not using the FX files, which were pretty much built for the whole thing, but you know, there's always the unorthodox way of doing things, and luckily XNA supports that. The shader format is different for the 360 and the PC, and the 360 cannot actually compile you the shader. So what you have to do is write your own little compiler, which is essentially one function call, but you have to specify that you're willing to use the Xbox 360 format. And what you have to do is that basically compile all your shaders for the PC and for the Xbox and just load them as binary data. And unfortunately, this makes the whole thing kind of like two-pass deploying thing, because you have to make sure that all the shaders are up to date for the PC and the 360. And you are probably a lot better off usually by just using effects files, unless for some reason you have to stick to like standard shaders and all that kind of stuff. I'm not actually sure if anyone else is willing to do that. You're probably better off using FX files and techniques and all that kind of stuff. One thing that should not be disregarded, and this actually slapped us in the face in literally the last minute, is the title safe area, which we read about and suddenly disregarded. And this is more of a technical thing. When you're rendering and you're displaying the whole thing on an analog output, like the component output of the Xbox or the composite output of the Xbox, there's an area of the screen that's called the overscan, which essentially is around 10 to 20% of the screen, the side of the screen. And whenever you render there, nothing will be visible. You basically get this zoomed in version of your picture, which literally means that if you have something at the bottom of the screen, top of the screen, on the far sides, that will not be visible, they will be clipped off. So that can cause a little problem when you kind of develop only on the PC and everything is really, sharp frame use and everything like that. And all of a sudden you realize that when you're running on the Xbox 360, everything is chopped off at the sides. Now, the problem with this is that there's no distinct pixel ratio for that. It depends on a lot of things. It depends on the television, it depends on the resolution you're using. So what you have to do is be aware of this. If you're doing something, just make sure you at least have an option to adjust the title safe area. So if someone else is running your game, running your demo, they can actually have a little menu just to be able to see the texts that are on the side, or the status bar for the game, or subtitles, or whatever is needed. This can actually cause an unwanted surprise, so to say. Now, one of the things we ran into, you have to realize that what we did last year is porting a C++ OpenGL engine to C# and Direct3D, which is XNA. And that's not a good idea. Our entire engine was written before the frame buffer objects came out in OpenGL 2.0. So everything in our post-processing was using what in Direct3D is called the stretch rect, or in OpenGL it's called the GL subtext image 2D or something like that. When you copy your frame buffer contents, your already rendered contents to a texture. Now I was browsing to the manual of XNA to see if it's supported, and luckily it was, and it works on the PC. And there was this little remark that said, on the Xbox 360, the resolve backbuffer command will clear the backbuffer, which means that your texture, your data from the frame buffer gets actually copied to the texture, and then the screen gets cleared. Now, this isn't an issue as long as you don't want it to blend it back. As soon as you want the whole thing to be able to use as blended back, like radial blur or some sort of like overlay, which we did. We used it for for the coloring of the whole thing. But as soon as you disregard that aspect, you have to actually write an Xbox specific method to render your texture back to the screen. And that's while it's not a big issue, and it's just drawing a full screen quad. The issue is the fact that you're losing time, you're losing frame rate, you're losing fill rate, because you're rendering the entire thing full screen, and full screen quads are actually really bad for the frame rate. And I'm not actually sure why the Xbox is doing it this way. What I'm thinking is that essentially what it does is that it has pointers for the textures and the back buffer and just swaps the two. And I'm not actually sure what it does, but I think this is the reason why it does that. Another thing that we felt missing is that when you're loading textures from raw data, you're not actually using the content pipeline to load JPEGs and stuff like that in. When you're using raw data, it doesn't generate the MIP maps for you. So you have to have your own MIP map generation call. And that's a bit of a problem. Well, not of a problem, because I mean MIP map generation is just like 3, 4, 5 lines of code at most. But it's something that you don't really want to find out late enough. So it's better if you already it's already part of your considerations that you have to actually have several paths. Both, I think it's not on the PC either, that you can't really generate automatic MIP maps for your texture data from the high level down. Now, Indianness is an interesting thing. If you have a lot of raw data, normally XNA is built for using JPEGs and TGAs and the X format and stuff like that. The X format is obviously a really good choice because all of the major exporting tools for major modeling software have an exporter for X. So you can pretty much just one-to-one export your data. But as soon as you're actually having some sort of data yourself, maybe you're having a demo tool that spits out timing and camera motion and splines and post-processing, filtering spline data and stuff like that. Once you actually have that problem, you have to realize that the Xbox is a power PC, while your PC is an x86. So the endian reading will be a bit of a problem. So, but luckily, a lot of the XNA framework is covering that. So if you're just using the standard Xbox stream reader for actually loading in floats, it will work. You don't have to actually change anything. But it is the x86 processors are little endian, while the power PC is big endian. So you have to actually take care of that as well if your code is like that. And my biggest gripe, really, which I actually vocally mentioned in the XNA forums, is that when you're using the content pipeline to load the music, you can play back the music and you can stop it, and that's about it. Now, I know this isn't an issue. The XNA thing was designed to have games, and games rarely have sound sync. But all you have to do is just go out this room, go to the back of the arena, and you see all the people playing Dance Dance Humiliation. And you will suddenly realize that sound sync can be important as games as well, especially when you think about the game called Audio Surf, which is probably leading one of the most bought indie games on Steam. It's a really important thing, and I talked to a man called Sean Hargraves on the XNA forums. He's a great guy, really helped us a lot with that. But he said that it's not in the plans to actually have any sort of sound features beyond the replay right now in XNA. And if anyone from Microsoft is watching right now, please do that. It's not that big of an issue. It's all you have to do is just return the sound pointer, and we'll take care of the rest. What you can do as a workaround is that you have to be able to, you can just use the really high precision timer of the Xbox itself and just place it next to the play call, and it will be accurate enough. Unless, of course, the assembly compo system breaks again. Now, there are also a couple of ideas, well, I had a couple of interesting things I didn't really understand when I was doing this XNA demo, and I'm really not sure what the hell was just happening. And one of the things was that the thumbnail, you can actually supply this little icon for your demo, and it when you're installing it on the PC, then you can just see it in the little installer. And when you're using it on the Xbox, the XNA Creators Club menu actually shows the little icons for the demos, and it's kind of cute. And I thought, why not use that? So I just made this high-res PNG because I wasn't sure what the limitations were. The documentation was somewhat vague about it. So I just made this really large one, and it said, sorry, the thumbnail has to be under 16K. Fair enough, I said. So I scaled it down, and the final PNG was around 10K. And I didn't actually try the deploying afterwards because I was busy missing the plane here to Helsinki at that point. And I did get a lot of reports from the compo team saying, excuse me, your demo is complaining that the thumbnail is too big and it won't install. Which is kind of an awkward moment you have, that your demo is actually running, it doesn't break, but the actual installation procedure, which you don't normally have, it's kind of like saying that, Unzip is having a bad day and doesn't want to unzip your demo, or your archive is password protected. This is kind of like something happening from where you wouldn't expect it, and it's really awkward. But it turns out that it says it's a fatal error and it's going to burn down the building, but it actually does install the demo afterwards. So it's not really an issue unless you get scared by the error message. Now, how to resolve that? It doesn't specify it. It has to be 16K uncompressed. It says only 16K, but it doesn't say that actually it converts your PNG, JPEG, whatever, to its own graphics format later, and the size for that is 16K up. So that's kind of something that it failed to mention. Another nice thing is that, when you're having an Xbox, the first thing you want to have is HD, and you want to have your demo running in 1920 times 1080. And for me, when I was trying to switch up to over than 1024, it had this device driver unspecified exception, access violation, whatever really long error message I couldn't comprehend and fix thing. So I actually had to keep our demo down at 1024, which wasn't a problem because our demo is alpha blending like a maniac, and I mean, even the Xbox has a limited fail rate before it starts to burn. And the funniest part was that I made this little routine that you can just, from any part of the engine, you have like this singleton class instance, you can just append kind of this little log messages to it, and it displays it like on the screen. And while I was making the demo, we were kind of finishing, and I was just, okay, let's test it in release mode. And the release mode had the whole rendering of the debug text removed, obviously. And the demo dropped down to 1/2 of an FPS, and I was going, what the hell? You're removing something that's rendering, and all of a sudden the whole thing dies. So that was a bit of a unexpected thing. And because it was 4 a.m. and my flight was leaving at 8, I kind of decided that I'm not going to search for the problem. I'm not going to actually debug the whole thing. So if you look at our demo from last assembly, you actually see the debug text with the alpha channel set to 0. So the debug text is actually on screen. It's just transparent. And these are kind of like the biggest what the hells I ran into when doing this kind of thing. I mean, I'm not sure these are the only things, and I'm not sure if these are the things that come from my personal error. They probably do, or these are like bugs in the XNA framework. But I just told these that if you run into these are the things to do. And by mentioning the debug text, make sure you remove the entire debug text routine, because what you will probably do is have some sort of function that keeps adding to the string that is actually rendering the debug and the final thing. And that's your biggest memory leak. That will be your biggest memory leak, because you will end up using 10 to 20K of text because it's in Unicode. You were using 10 to 20K of text every frame. And after 60 frames, the garbage collector is going to step in your face, and that's going to be a problem. And that's something you found out only after we released, and our demo was jittering and stuff like that. And now a couple of final advices I would like to give is that, first off, pre-parse your data. Make sure if you have mesh data, if you have texture data that cannot go through the content pipeline, make sure that everything is in the correct component order for textures, and you don't have to like parse text and all that kind of weird stuff. You would normally, on a PC demo, it would work because, I mean, PC non-managed code is really fast when it comes to working with memory. The only problem is that, well, in managed code, because of the name managed, every memory operation is strictly monitored by the framework itself. So if you were just, we had this issue that we wanted to load the texture data. It was raw 32-bit texture data. We could just load it in. But the RGB channels were switched, because that's how it worked in OpenGL. So we had to actually switch it in the loading time, and it was that's why our demo actually loads for like 1 to 2 minutes, because it just does all these like menial stupid things. Another thing about it is that use more small files. Break up your data into small files instead of having 100 megabyte data file like we did. Because XNA has this really nice thing about a content pipeline, is that everything you include in the project is copied up to the Xbox and you can read from it. All the JPEGs and data, raw data files, you can actually copy them up. Now, the thing about it is that it will keep them there. And once you've changed something, it will copy it again. And this is where you can understand that having 30 files, each like 1 megabyte, and then one changes, then it's only one copy. When you have 100 megabyte file, deploying the whole thing is actually taking minutes. And it gets really, really frustrating after a while. And that also ties into the next point, which I have, is that do actually test as frequent as possible on 360. You can't actually do that you finish your demo on the PC, you're full featured and it's running, and then you want to test on the 360 and it doesn't work, or it has all sorts of exotic bugs. Now the problem you will run into is that you already have all the features running, and you don't know which one breaks, and you don't know how many. There's a lot of issues. I mentioned them, that several things work differently on the Xbox. And you will not find out unless you actually know that you have 3 features running, 2 of them are correct on the Xbox, and I just added the new one, and it doesn't work. Because at least it breaks down the amount of code that should be debugged to one procedure or something like that. So please do actually debug on your Xbox as well. XNA Game Studio actually supports debugging line by line. So if you have some sort of like uninitialized kind of thing or something that works differently on the Xbox, you can actually step-by-step debug the whole thing, and it's kind of cool when you just press pause and the whole thing stops on the screen, and you just press resume, and your demo keeps running again. That gives you this God complex over the whole thing. And the final and best advice is probably that be aware of what you're doing. A lot of people having a problem with either thinking too low level, too old school, of just pushing bytes and just throwing values into certain spaces and making sure that it ends up in a raster bar. And the other type of people is who think too high level and start to build rocket science while they should be actually just making a demo. The good path is obviously somewhere in between. And XNA kind of supports both, but it's always kind of good if you listen what their manual and what their preferred management of data is saying. The reason for that is that they don't say that for marketing. They say that because they wrote the thing. Essentially, it's their list of bugs you have to avoid. When you're actually writing code and they say you should be running it through FX files to the content manager, they say that because of, for example, the different shader format on 360, and there's no compiler on 360, and so you don't have the chance to actually do that as simple as you would be doing with FX files. So there's a reason there's a manual for it. The same thing for Dyro3D. They have the debug version and stuff like that. It's very high level. But also you can work on the low level of just twiddling vertices and loading vertex buffers and all that sort of stuff. So just use your head when you're building your engine. That's the ultimate thing, that what we didn't essentially do. But basically, we built the whole thing in 2 weeks without sleep, pretty much. And then I just ended up missing my plane with around 10 seconds when the check-in closed. But we did get 5th last year, and I guess that was worth it. And I would really enjoy to do an Xbox demo once again with XNA. And I would have done that hadn't it been to Grand Theft Auto 4. So that's essentially what I was trying to convey. And now it's your turn. Now it's your turn to sit down, code, make a good demo, make a good game. And it's your turn to ask a question, if you will. Oh, that's nice. You don't have to pick this up this time. So if there's a question, I will be gladly answer it if I can. Please ask questions. That makes you show that you're interested. Okay, point taken. Well, thank you then.